Hello, PreCalc. Here we are with 4.2. We're talking about the unit circle. Should be familiar to you from last year in Algebra 2. Okay, it's called the unit circle because it is on a circle with a radius of 1 unit. X squared plus y squared equals 1. Okay? And then they're going to imagine that a real number line is wrapped around the circle with positive numbers corresponding to a counterclockwise wrapping. And that is going to be where they place the radians. Okay, think about the little tick marks around the outside last year where you had degrees and radians. They're basically going to be only referring to radians, so you're going to need to get used to those. All right, and then their x comma y. You know the x1 goes with cosine, and the y coordinate of your point there corresponds to sine. Okay? They make it sound all complicated, but it's not. All right? Just all the tick marks along the outside of the circle correspond to the radian measures, and whatever the x coordinate is at that position is your cosine value, and the y coordinate will be your sine value. And from there, we can get everything else. Because tangent is sine over cosine, cosecant is 1 over sine, and secant is 1 over cosine. Cotangent would be cosine over sine. Alright, so we can do that. Not too bad. Let's jump on down here. They try to make it sound tough. It's not that tough. Okay, so if you see like sine of t, t is just going to be the radian that they're going to give you. All right, example, when t equals pi over 2, that's going to match up to 0, 1. So that would be cosine 0, sine 1. So tangent would be having cosine on the bottom, and if cosine 0 on the bottom, it's going to be undefined. Same thing with secant, because secant's 1 over cosine. Okay, they're just working on, here is your counting by fourths, 0, pi over 4, pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, back to 0. Okay, remember the pi over 4s are going to be your radical 2 over 2s. And you just got to know which one's positive and negative. And then the pi over 2s, or full pi's, like 0 pi, pi over 2, 1 pi, 3 pi over 2, are going to be zeros and ones. Sometimes negative ones. All right? When you're talking about the pi over 6s, okay, and again, pi over 6s turn into pi over 3s, and 3 pi over 6s would turn into pi over 2s. You get a lot more pieces of the puzzle when you look at it like that. You'd have everything, when you're counting by pi over 6s, you'd have everything except the pi over 4 spots. Okay? At the pi over 6 and pi over 3 positions, you have radical 3 over 2, comma a half. So at the pi over 6 positions, 1 pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, you have the radical 3 over 2 in the x position and the half in the y position. And then you just got to remember positive and negatives. For the pi over 3 positions, 1 pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, it's flip-flopped. The half is in the x position, and the radical 3 over 2 is in the y position. And again, you just got to remember the negatives. Okay, so let the fun begin. What are the 6 trig functions at pi over 6? So I'm just going to do a quick little sketch. Pi over 6 is not very far up. Okay, so it's more out. That means the x is going to be the long one. radical 3 over 2, comma, a half. Okay, that's x comma y, that's cosine comma sine. So already we know 2. Okay, so sine equals 1/2, cosine equals radical 3 over 2, tangent is sine over cosine. Okay, multiply by the reciprocal, 2 over radical 3. 2 on the bottom cancels the 2 on the top. We have 1 over radical 3. Can't stop with that on the radical on the bottom. So you multiply top and bottom by radical 3 over radical 3 there. And we get radical 3 over regular 3. And then the inverse or sister functions, or whatever way you know them as. Okay, if this one starts with an S, its partner is going to start with a C. So secant would be flipped, 2 over 1. Okay, cosine goes with secant. Flip it, 2 over radical 3. Can't have a radical on the bottom. 2 radical 3 over regular 3. And so this is where it's nice to kind of have your work. Okay, radical 3 over 3, when I flip that, that's going to have a radical on the bottom again. But I know this is equivalent, and if I back it up a step, it's equivalent to this, 1 over radical 3. And if I flip that, I get radical 3 over 1, or just radical 3. If you flip this, you'd have to radical 3 on the bottom, you'd go through those steps again and simplify, and you get the same thing, radical 3. Alright, let's do a fun one here. Because that one wasn't fun. Let's do a fun one. Pi over 5, pi over 4. Again, I like to do a little quick sketch. We got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So we are negative, negative. That's going to be negative radical 2 over 2, comma negative radical 2 over 2. Sine, cosine, tangent. Makes the tangent one easy. Okay, so sine, negative radical 2 over 2. Cosine is also negative radical 2 over 2. Tangent, you got one thing divided by the same thing. I'll show the work here, but it's the same thing divided by the same thing. It's going to be 1. Okay, partner is CSC, cosecant. If I flip this, we have, I'm going to run over this little space here, negative 2 over radical 2. We'll show you the long work. Radical 2 over radical 2. So we have negative 2 radical 2 over 2. Those are going to cancel out, and it's just going to be negative radical 2. I spilled into the other one, darn it. Negative radical 2 if we simplify. Okay, cosine is going to go with secant. It's also going to be negative radical 2. Tangent, we flip negative 1, it stays negative 1. Oh, this is positive. Negative over a negative is a positive. That's an equal sign. That's part of the equal sign. It's 1. So cotangent is also 1. Negative over a negative is a positive. One more. We kind of spilled into this one. Let's go over here. Pi. Okay, at pi, we have negative 1 comma 0. So this is going to give us some interesting things here. Sine is 0. Cosine is negative 1. Tangent, sine over cosine. 0 over negative 1 is 0. We can do that. Now the partner functions. Cosecant, if I flip 0 upside down to 1 over 0, that's undefined. Okay, can't divide by 0, undefined. Okay, if I flip -1 upside down, it's going to stay -1. And then if I flip this one, this was 0 over -1. If I flip this, now it's -1 over 0. And that is undefined as well. So undefined, -1, undefined. Remember that you can't divide by 0. Okay? Example 2. -2 pi over 3. So remember that negative, you're just going to spin the opposite way. We're just going to spin the opposite way. So -2 pi over 3. If the negative's messing you up, you can just add plus 2 pi, or that would be 6 pi over 3. And then we'd have positive 4 pi over 3, if that's easier for you. 1, 2, 3 pi over 3 would be pi. 4 pi over 3. Okay, or you could look at it this way. Right, there's 4 pi over 3, or we could look at it as -1, -2 pi over 3. Just whichever way you want to go, it's the same thing. -1/2, comma, negative radical 3 over 2. Okay, this one's interesting because you're going to have some fractions with radicals again. So far it starts off pretty easy. Sine, we got negative radical 3 over 2. Cosine is -1/2. Tangent, sine over cosine. So we have negative radical 3 over 2 over -1/2. Multiply by the reciprocal times -2 over 1. And the negatives would cancel, and we're left with just a positive radical 3. Okay, what happens if I flip this? Cosecant, -2 over radical 3. Can't stop with a radical 3 on the bottom. Multiply both top and bottom by radical 3. I don't know if I mentioned this the first time I did it, but why can we do that? Okay, normally if we have an equation, you have to do the same thing to the left and the right side of an equal sign to keep it balanced. We don't have an equation here, we just have a number, a rational expression of a number here. So why can we do this? Because you're multiplying it by radical 3 over radical 3. What's radical 3 over radical 3? Radical 3 divided by radical 3 is 1, and 1 times anything stays that same thing. So we're not changing the value of -2 over radical 3. We're just kind of changing how it looks. Okay? So we'll have -2 radical 3 over a regular 3. And I know there's more pieces. There's 3 pieces, and there was 2 pieces. It's just bad math grammar to finish with a radical in the denominator. I didn't make the rules. I just play by them. Okay? We're going to flip this. Secant. This is an easy one. Flip that. It's -2. All right. And flip this to cotangent. It's 1 over radical 3. Again, can't stop with that on the bottom. After you do them enough, you start to figure it out. Or some of you probably have a little trick already that you do. Radical 3 over 3. Okay, if you have a little trick from your previous teacher that you do, feel free to share that with the others in the class. I just usually draw it out and do the work every time, and after you do the work enough times, you just remember it. You just remember it. Or you forget about it after you don't do it for a year, and then it comes back pretty fast when you start doing them again. Page 3. Almost done. Okay. Domain of sine and cosine is all real numbers. The range is just bouncing back and forth between -1 and 1 as we keep going around. Okay, because sine is your y values, and the y values on the circle keep bouncing back and forth between 1 and -1. And the cosine y values, or the cosine is the values here are the x coordinates. And those just keep circling back and forth between -1 and 1 as well. Adding 2 pi to each value of t in the interval can complete a second revolution around the unit. Okay, the values of t plus 2 pi, sine of t plus 2 pi, and cosine of t plus 2 pi correspond to those, and they're the same values as t for both of those. What does that mean? So, example, sine of, let's see, just make it easy. Pi over 6, okay, is the same thing as plus 2 pi plus 12 pi over 6. This would be the same thing as 13 pi over 6. Okay? Here's pi over 6. And then 13 pi over 6 is all the way around the circle, and then back to that same spot of pi over 6. It's going to be the same thing. So then they're saying this is periodic because it happens every loop. Okay? Functions that behave in such a repetitive or cyclic manner are called periodic. A function f is periodic if there exists a real number, a positive real number c, such that f of t plus c is equal to the same thing as f of t. And we know that happens on the unit circle. It just keeps going around and around and around and around. For all t in the domain of f, the smallest number of c for which f is periodic is called the period of f. Recall that a function of f is even if f of negative t equals the same thing as f of positive t, and it's odd if f of negative t equals negative of the function value at positive t. Okay? So an even one, f of x squared, right? Like, think about it here. Negative 3 squared equals 9. Positive 3 squared equals 9. Okay? And an odd one, x to the third. Alright? 2 to the third equals 8. Negative 2 to the third equals 8 with a negative. So negative of 8. Okay, that's kind of what they're saying there. Cosine is even, and so is its inverse or sister function there, secant. Sine is odd, and so is tangent. And then their partner functions are also odd as well, obviously. Okay? Last page. All right, so there it is, sine of 13 pi over 6. Okay, you can go the long way. 12 pi over 6, 13 pi over 6. Or you can subtract 2 pi minus 2 pi. 12 pi over 6 would reduce to 2 pi. And it's going to be the same position as pi over 6. What is sine at pi over 6? It's pretty far out, but it's not very far up. Sine is a half, because that is radical 3 over 2, comma, a half. Find the cosine at negative 7 pi over 2. So the pi over 2 ones are pretty easy to count, because those are your axes there. Okay, so you could adjust it if you wanted to and get it down into like a normal 0 to 2 pi kind of a deal. Otherwise, just negatives are going backwards. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7 pi over 2. And that is 0, comma 1. Cosine is the x. That is 0. Okay, let's say you wanted to get it positive. So you're going to keep adding 2 pi. Well, 2 pi, we have over a 2. That's 4 pi over 2. So negative 7 pi over 2 plus that 4 pi over 2 would be negative 3 pi over 2. Well, it's still not positive. Let's do it again. Plus another full circle, pi over 2, 4 pi over 2. And we get positive pi over 2. And that's where we ended up. Just a positive pi over 2 that way, or it's the same thing. It's pretty easy to do. Count backwards, 7 pi over 2s. Last one. Okay, pay attention here. Sine of t, they're not telling you what the t is, what radian it is. They're just saying some sine of t equals 4/5. What would sine of negative t equal? Okay, we know that sine is odd, so sine of negative t would equal negative of whatever sine of positive t was. We know positive t was 4/5, and thus we get negative 4/5. All right, you should have a calendar getting passed out to you today or yesterday, so you have that for your homework. Check them out. Solutions are posted on Schoology, and there should be a big fat book with a purplish pink cover on the back on the teacher's desk there if you want to look through that for the solutions. Otherwise, they are scanned in on Schoology. All right. Thanks for watching, kids. We'll see you next time.